All right, so today we're going to be working with simplifying radicals. We're going to start back with recalling our perfect squares. So you can see here I have a table of perfect squares that I highlighted. So our perfect square numbers are 1, 4, 9, 16, 25, 36, and so on. And then I added actually a couple on the side here where I have 13 squared is 169, 14 squared is 196, and 15 squared is 225. The more you are aware of these perfect square numbers, the easier it is to simplify your radicals. If you don't, the process will just take a little more time. So again, these are really good to know. And the reason why I included these three on the side is I feel that these pop up quite often in some of the problems that we're going to do in this chapter for our triangles. So again, really good to know, be mindful of them. So now we're going to go and look at simplifying radicals. So here we have, for example, if I have 3 squared is 9. If I want to take the square root of 9, I'm asking what number times itself gives me 9. So that would be 3. So again, that symbol here, that radical symbol means to take the square root. It is not division. We are not dividing by 2. We are finding a number times itself that gives us the number underneath the radical symbol. So now when we have a square root, we actually get 2 solutions. We get a positive and a negative solution. So here, when we have the square root of 9, we talked that one of the answers was 3. What other answer could it possibly have? So again, remember, it's thinking about what number times itself would give me positive 9. And the answer to that is negative 3. And that's because, remember, negative 3 times negative 3 is positive 9. Now, throughout the duration of this lesson, we're going to focus only on the positive answers. Moving forward and outside of this course, be mindful that there are going to be 2 solutions when you're solving a square root. Also, we cannot take the square root of a negative number. For instance, we cannot take the square root of negative 5. Cannot. We would just say we cannot take the square root. No solution. Moving on to the next course, you'll learn more about that later on. Okay, so let's try some information that we've seen. All right, so here it says simplify the radical expressions below. So let's start off with the square root of 100. Square root of 100, 100 is perfect. What number times itself gives me 100? Okay, so the answer here is 10. Again, we're only focusing on the positive answers here, and that's the only answer I will be writing. All right, moving down, the square root of 25. What number times itself would give me 25? So here we have 5. Square root of 144. Here would be 12. So again, these are all perfect numbers under that square root symbol, making the problem pretty easy to deal with. Here we have a little more algebraic. So here we have the square root of x squared. What that really looks like is the square root of x times x. You should know that x squared means that we're timesing x by itself. So now we want to know, what is the square root of x squared? And that is simply x. Think about it. You told me 10 times 10 makes 100, so we knew the square root was 10. Here we know x times x is x squared, so our answer here is x, just in a variable form. All right, our next example in this section, here we have 4x squared. We're going to break this into 2 problems. We have the square root of 4 and the square root of x squared. What is the square root of 4? That would give me 2. And the square root of x squared, as we just did, is x. So the square root of 4x squared is 2x. Now, what happens when it's not perfect? When it's not perfect, we have to do a little bit of work. So we have to know our factors to help us. So since 24 is not perfect, to simplify the radical, we need to factor it. So we are going to figure out the factors, and one of those factors must be a perfect square. And when I mean perfect square, I mean some of the numbers that we listed in the previous chart. 1, 4, 16, 25, and so on. So now I would like you to list the factors of 24 as I list them. We want all the numbers that make 24. So here I'll have 1 and 24, 2 and 12, 3 and 8, 4 and 6. Again, you didn't have to put them in order. I like putting them in order. It just helps me see it better, right? Which of these is the highest perfect square? So looking at our list, we have to go back and figure out which one is our perfect square. 1 is perfect, 2 is not, 3 is not, 4 is perfect, 6 isn't, 8 isn't, 12 is not, and neither is 24. So which one is the highest? 4 is our highest. So we're going to use 4. What number times 4 makes 24? So that is 4 and 6. To do this method that I'm showing you right now, you have to pick the highest perfect square. So because we have the square root of 24, I could break it into our factors. I could say 4 times 6. So then I could say, well, I have the square root of 4 and the square root of 6. The square root of 4 is our perfect square. It is the highest perfect square in that number. So we know the square root of 4 is 2. The square root of 6 cannot be reduced any further, and it will stay square root of 6. So the square root of 24 equals 2 square root of 6. I'm not very big on this method, especially if you're not comfortable knowing your factors or the highest perfect square. I prefer using the factor tree method, which I'm going to show next, using the same types of numbers. So using our factor tree, we're going to use prime numbers to go through our problem. So I'm going to break 24 down into 2 numbers that multiply to 24. It could have been any combination. It could have been your 2 and 12, 3 and 8, 4 and 6. For this example, since we already did 4 and 6, I'm going to pick 3 and 8. So we can stop at any time we have a prime number, and anything else needs to be continued to be broken down. So since 3 is prime, we're going to stop there, and we're going to continue to break down 8. What 2 numbers multiply to make 8? So I have 2 and 4. I'm going to kind of cross out 8 so I know I used it. So now I know I have 3, 2, 2 is prime. Now we're going to go to 4, and I have 2 and 2. Again, kind of cross out that 4 so I know I used it. So here are all the factors that make 24 in the prime factorization method. So what I like to do is I like to identify a pair that match. They don't have to be next to each other. I take a pair and I write it once outside the radical symbol, aka I call it the house sometimes. So we write that once, and then the other 2 get multiplied inside. So I have 3 times 2. Here's that 3, here's that 2. What is 3 times 2? Here we have 6. This is the same answer as we got from that list method. Again, I prefer the prime factorization method, aka the tree method, and that's what I'll be using for most of my examples. All right, so let's try a few more. All right, I'd like you to try number 1 on your own. Again, utilizing that tree method, you're going to pick 2 numbers when you multiply them that make 32. All right, I'm going to start, and I am going to pick 16 and 2. Again, you didn't have to pick 16 and 2. You could have picked 4 and 8. It doesn't matter, as long as they created 32 when they started. So I know that 16 can be broken down. So 4 and 4 and 2. Now I'm going to kind of cheat just a little bit. Since this is a pair, I'm going to circle it. And that is my number I'm going to pull out in front of my house, or square root symbol, and then 2 goes inside. And this is my answer. I am going to show this one more way. So I'm going to show this by picking 4 and 8. So if you picked 4 and 8. So here this goes down to 2 and 2. Again, I'm going to cross it out as I break it down. Here this is 2 and 4. And this is 2 and 2. All right, so here we have our list. We have 1, 2, 3, 4, 5 2s. This is one pair. This is a second pair. So what that looks like is it's going to be 2 times 2. And then the last 2 gets on the inside. 2 times 2 is 4, square root of 2. So again, it's all about the numbers that you pick, breaking it down. All right, so I'd like you to try number 2, breaking down that 75. And let's see what we get. All right, so for this problem, to break down 75, I picked 25 and 3. I could break down 25 to 5 and 5. 5 and 5 create my pair, so I'm going to circle that. And now I have 5 square root of, there's no pair for 3, 3 gets put inside that radical symbol. Now that is for square root of 75. However, we have a 2 in the front, so that 2 gets brought down, and we're going to multiply that. So it's 2 times 5, so this becomes 10 square root of 3. So 2 square root of 75 is now 10 square root of 3. All right, and in number 3, we have the square root of negative 4. So what is the answer of square root of negative 4? What two numbers can I break that down into? So here, remember, we could have negative 2 and 2, but that's not a pair. And we're kind of just stuck there. So this is not possible. Remember, we cannot take the square root of a negative number. All right, so now we're going to talk about addition and subtraction using our radicals. So we want them to be in simplest form when we add or subtract. So what that means is we want the radical symbol to be simplified as we've been doing in the previous problems. When they have the same radical, we have like terms and we can combine. So here you can see we have the square root of 5 in both of these problems. So they are like terms. So how I can add this is 2 plus 7, which is 9. And we keep the square root of 5. So we add or subtract, depending on what we're doing, outside number, and then we keep the radical number. Again, we want to make sure that radical is simplified. All right, so I'd like you to try number 1. All right, so now let's look at number 1. Here we have 3 square root of 7 and square root of 7. In front of 7, it's an imaginary 1 there, understood to be a 1. So here we have 4 square root of 7. Right, and number 2, they both have the square root of 2, so again, common. So now I'm looking on the outside. Negative 6 minus negative 3, so that's negative 9. Square root of 2. So now my answers are simplified. All right, we're going to take it up a little bit further, still with addition and subtraction. So it says, make sure the radicals match before you add or subtract. Always check if you can simplify the radical. So looking at number 3, we have 3 square root of 27 plus 4 square root of 3. 4 square root of 3 cannot be simplified. It's all ready to go for us to use. But 3 square root of 27 needs a little bit of work that we need to simplify first. So we're going to break down 27, and I'm going to pick 9 and 3. 9 can be broken down further to 3 and 3. So now I'm going to identify if I have any pairs. And I do. So I have 3 root 3. Now, there's a 3 on the outside like there was in the previous problem, so we bring that down. And now we have an extra step of multiplication. So 3 times 3 is 9 square root of 3. Okay, so that is taking 3 square root of 27 and simplifying it. So now we're adding 4 square root of 3. Now, do we have matching radicals? We have square root of 3, we have square root of 3, so we do, and now we're going to combine. So when we do, what do we get? Right, we get 13 square root of 3. Because all we're doing is we're adding the 9 and the 4 together. All right, so now let's look at number 4. Number 4, we have 3 square root of 45 minus square root of 125. Both of these radicals need to be simplified, or checked if they can be simplified. We do them individually and then subtract if we can. So we're going to start with the 45. So I have 9 and 5. 9 can be broken down further to 3 and 3. Again, I like to cross out as I go so I know it's not there anymore. So here's a pair. So here I have 3 square root of 5. There is a number on the outside, so we drop that down. And now we have a multiplication problem. So now we have 9 square root of 5. I'm going to bring the minus sign down as well. And now we're going to simplify a square root of 125. When we break this down, I pick 25 and 5. Now, if you don't know what number to pick, this is when you really use your calculator and you see 125 divided by 2. Does that work? 125 divided by 3. Does that work? 125 divided by 4. I always start with 2 and just keep going up and seeing what pair works. And then I write it down and continue on. So we know that 25 can be broken down to 5 and 5. Cross out that 25. Here we have a pair. So here I have 5 square root of 5. There's no number in front, so I just bring that down. And now we check. We have matching radicals, and now I can combine 9 minus 5. So here I have 4 square root of 5. All right, and now we're going to try one more skill. Our last skill deals with a little bit of fractions. It's called rationalizing the denominator. The reason why we are working with this fraction is because we have a radical in the denominator. We do not like that, nor do we want that. That's like having a decimal in the denominator. We really don't have that. We need to clean that up. So we are going to clean that up, and I'm going to show you the first one on top. So here we have 1 divided by square root of 2. To rationalize the denominator, what we do is whatever number this bottom is, I'm going to multiply the top and the bottom. So I have square root of 2 over square root of 2. If that bottom number was square root of 10, I would be multiplying by square root of 10 over square root of 10. It doesn't matter. Whatever the number was is what I want to keep it as. As you can see, this fraction that I created is still a 1. So I'm not changing the value of the problem. I'm just changing how we're seeing it and what it looks like. So we're just cleaning it up a little bit. So when we multiply, we're multiplying straight across. So 1 times square root of 2 is square root of 2. And on the bottom, square root of 2 times square root of 2 is square root of 4. When you do this problem at the bottom, your bottom number will always become a perfect square. That's the goal. So on the top, I have square root of 2. On the bottom, it becomes 2. Square root of 2 and 2 are not like terms. There is nothing else to simplify, so this is our final answer. All right, so I'd like you to try the next one. We have 2 divided by square root of 6. What am I going to multiply the top and the bottom by in this problem? All right, so we're going to multiply by square root of 6 over square root of 6. All right, when we multiply straight across, what do we get? All right, we get 2 square root of 6. They are not like terms. So we're not going to get square root of 12. They are separate. So we just put them next to each other. 2 times square root of 6. On the bottom, when we multiply across, we get square root of 36. Again, 36 is perfect. So we can simplify. So here we have 2 square root of 6 over, and remember, square root of 36 is 6. Now we have to check, can we reduce? We always need to check if there's anything we can simplify. So in this case, we have like terms. The 2 and the 6 are like terms. What can I reduce by for the top and the bottom? So I can reduce the top and the bottom by 2. So here I have square root of 6 over 3. And that is rationalizing your denominator. So make sure you have these notes, and we're going to practice more in class.